That's better. Hi, welcome to the HTTP authentication working group meeting. I suggest everyone come to this side of the room because we're simply not there, and there's plenty of seats on this side. I'll start the blue sheets going. If you've ever been to an IETF meeting before, you might have seen this at some point. This is the largest font I could manage, and I think it's fairly legible, at least from this distance. So we have a short meeting today, just 1 hour. So the blue sheets are already circulating. Make sure you sign it. We've seen the note well. Scribes, is Joran in here? Huh. Well, he kind of volunteered to take notes. Anyone else can take notes? Okay, so we'll hope he gets here by the time we finish with the administrative stuff. How about the Jabber scribe? Anyone in the Jabber room? Ah, here's Joran. Thank you for volunteering to take notes. Okay, so we need somebody in the Jabber room. I don't think we have any remote participants that we know about, but there could be some that we don't know about. Okay, we're going to do document status, then we're going to see a presentation about our current working group document, which is CRAM, and then we're going to see a couple of presentations about proposed items for this working group. And if you have time, open mic. So, as I said, blue sheets, note well, scribes. Oh, so anybody in the Jabber room? Anyone at all? Come on, people. It's easy. Fine. Do I have to start naming names? Okay. People are so afraid they don't even have their laptops open. Because, if I see anybody with a laptop, I'm going to say you. Yep. Okay, well, let's see how that goes. Which leaves us with the case of the missing chair. As you can see, I'm alone here. And the reason for that is that Matt Lipinski has accepted a new job as he has a teaching position in some college just starting a computer science program. So good luck to Matt. And right now, if anyone of you has some experience with the IETF, no need for a lot, and is somewhat knowledgeable about HTTP authentication, is willing to do it, and is not a current working group document author, you're welcome to come talk to me or to Kathleen, and we are looking for a new chair. Okay, or something else that we'll talk about in a minute. Document status. So Basic and Digest are now in the RFC editor's queue. Both are pretty much done. They're at the top of the queue, except they're both waiting for the Précis document to be finished. After that, it's just Auth48 and they get published. So Scram hasn't seen much discussion on the list, and we're hoping to change that today. Which leaves us with, why is space going backwards? Mutual loss. We've had no progress, despite a lot of goodwill at the meeting last time. So we're going to try a new plan. The author is going to prepare an issue list. He already started it. So we'll post 2 to 3 issues at a time to the mailing list. And this is something that's already worked in another working group. What we're going to do is say, okay, this is an issue. We propose to close it by making this change, or just closing it and not making any change. And if anybody feels that this is not the wrong conclusion to this problem, then speak up now, because we're going to close the issue in 2 weeks. And then if nobody speaks, we close the issue in 2 weeks, as was proposed. If during the discussion some other issue comes up, we add that to the list. And when the list goes down to 0, we go to working group last call. Yes, Alexei.
Question, are you going to use track or something? It would be useful to have a list of all issues, including the ones which are closed, in case they need to be reopened in general, just in one place.
We can use track, or we can use GitHub. The documents are now on GitHub, so both of them are good.
Okay, so
yeah,
the responses were, we can use track or we can use GitHub, because a document just got published on GitHub today. So
yeah, so either way, as long as it's accessible, yeah. And although this slide says that it's the document authors doing it, I don't think that's really the best idea. If we don't get a second chair, we can get somebody to be a working group secretary and do this on the list. I think that's great experience for somebody who hasn't been a chair before. And well, if you don't want to propose yourself as a working group chair, working group secretary is also a great option. So talk to me, and if you want to be a chair, talk to Kathleen as well. But you can talk to me first. So are people comfortable with this process? Okay. Good. So why not try that? Because otherwise we really can't make progress. And this is too big a document to go the individual route. I mean, this is not something that I would feel comfortable if it was AD sponsored. Okay. Not that they have much to say about it if it's AD sponsored. Okay. And for some reason, oh, that's the last slide, because now we have slides for the other presentations. So, Alexei?
you'll have to stand in a pink box.
Yes, you should.
Okay. Right, so last time we talked about this document was in Hawaii, I think. I did 2 updates, 2 revisions. Next slide. So one big discussion in Hawaii was about initially the HTTP Scram was slightly different from SASL Scram, so you couldn't quite reuse the libraries as is. So now there is an extra base64 encoding of Scram data, but then you can use existing SASL libraries just to deal with this information. And all HTTP specifics parameters are represented as HTTP directives for WW Authenticator authorization directives. The other changes, I've changed to SHA-256 as mandatory to implement. SHA-1 is still there for most of our backward compatibility with Scram SASL, so just registering both of these. ABNF got updated, and there were various fix-ups to the authentication mode. I initially sort of sketched how it's going to look like, and then when I thought about it, there was some missing bits, so I clarified that.
So regarding, so regarding that SHA-1 is still there, Stephen is not here because ABFAB is meeting in the other room, but do you think this is going to generate a discuss, having SHA-1 at this day and age?
I don't have strong feelings about this. However, one of the reasons for having this is so that you can, share libraries. So existing libraries mostly support SHA-1. On the other hand, one implementation I did is written using OpenSSL, so changing hash is very easy. So if people want me to take it out, it's fine. For now, I don't think it's something we
is there a reason to keep it? Because I'm not hearing a good enough one, and I agree with Yoav. It'll be a lot easier to just
the reason
take it out
is
there's a really good reason.
Maybe a bit speculative. So let's say I have a IMAP server and CalDAV server packaged together, calendaring and mail, and they use the same underlying library underneath. One can implement HTTP Scram, the other one will implement regular Scram SHA-1. But I suppose might not be a good enough reason not to upgrade. So
this is Chris Newman at the other microphone.
Hi, Chris.
Yeah, if I could respond to that, I can. Is there a line?
Go on.
Yeah, so I was going to say I think the real advantage to using the Scram is it has the server-side hash now has two functions. Not only does it obfuscate the password, but it also allows a non-plain text authentication where you're not reusing your password on all servers, or where you don't have that weakness. So, most sites, if you just do password-based, they're just going to they're just going to do some random hash that doesn't have any authentication protocol you can use that same hash with. That's better than plain text.
I think you are answering the wrong question. The question was currently the document both Scrum SHA-1 and Scrum SHA-256. People asking to take SHA-1 out.
I have no objection to taking SHA-1 out.
Well, he's one of the co-authors on Scrum, so I think that's fine.
Yeah.
Fine. Next slide. The most list of open issues, there are really only 3 things, and I think on one of them I'll just do nothing. On the other 2 is, let's start with the easier one. I'm sorry, I think this might have been discussed in Hawaii, in Honolulu, but I don't remember the answer. With the authentication mode, Digest has a stale directive that signals the client that the nonce is stale, so you have to redo the full handshake. Do we need something like this here? I think people might have said yes, but I don't remember. I couldn't quite find what was the outcome of this discussion.
I'm Yuta, so I think the answer should be yes, but I'm not implementing, so you need to distinguish whether the authentication has been failed or just the key must be renewed. So if the Scrum do not have that function inside, the answer will be yes.
Yeah. The difference, without this directive, when the server responds, no, you need to do a full handshake, the client doesn't know whether it needs to pop a dialog and say, try a new password, or whether they should just retry with the new nonce. So probably a good idea to add this. The other thing is username password canonicalization. I think we're discussing of referencing SASL PrepBIS document, and it's finally, I was updating slides, you know, it was SASL PrepBIS version 6, and now it's 18, so there were quite a lot of changes. So I think I will do these changes, and the rest is mostly editorial, just proofreading. And can you switch to the next slide? Yes, switch the next slide. Right, so proofread, try to implement the authentication mode. Also, I think Tony implemented the SHA-256 version, yes? So I will ask you to do new examples, or help me with examples. That would be maybe. Okay, that's it really.
Okay, so do you think this could be up for working group last call before Yokohama?
Yeah.
Cool. Give us a steady pace of one RFC per meeting.
All right.
What do you mean by implement? You mean you need some help to check whether it works in the real software?
So for the 2 round trip, the regular mode is already implemented, and I know there are implementations. So I am relatively happy that the way it's described is correct. For the authentication mode, I want to make sure that it's correct and implementable, that it's not missing any details which are in my head for, so.
Tony Hansen. In the current draft, you have in your examples, you're using data equals, and then you say base 64 of whatever. Are those placeholders for?
Yes.
Okay. So, yeah, my suggestion is that you actually put the base 64 there and have a comment.
Yes.
Saying that's the.
I didn't want to leave just base 64 there because it needs to be base 64 valid protocol anyway. So because I will ask you to generate new examples, then I can, you know, if you just do the correct one, and then I can also add a comment saying, and if you base 64 decoded, this is what it looks like, so that people can verify internal states and stuff. So I'll.
Excellent. We're on the same page. Thank you.
Okay. Just let me get the next thing. That's the one. Oh, that was the one I wanted. You write this here. Oh. Never use a beta version of Microsoft Office. Okay.
Okay, next slide, please. Okay, so during the review of the HTTP digest draft, the Security Directorate and the Gen Art review suggested adding support for HMAC. And also the stun-based team suggested adding a salted hash to the digest. So this proposal is just to discuss those two issues here. Next slide, please. So currently, the digest mechanism defines 2 functions. One is H, which is just a hash, simple hash. Another is a derived key or key digest. So that key digest is supposed to be a keyed mechanism, but in reality, what happens right now is that it's just a hash of that concatenation of the secret and the data. with the new mechanism, if we add a HMAC support, it will become a real keyed digest. And the second part is adding that salt to the value we calculate, which is A1, right? So these are the proposed changes to the existing functions to allow us to support those HMAC and the salt. Next slide, please. So to do that, we need to add two parameters, or we need to add one parameter, which is the salt. In this case, is going to be returned in the challenge from the server to the client for the client to do the right calculations. And we need to update the hash, the algorithms to add support for the HMAC algorithms. Next slide, please. And examples here. So A1 will include the salt. HA1, for example, will use a SHA-256 as an example, and a response will be a keyed digest. So HA1 will be the key, and the rest will be just the message. And so that's just a simple example of the change that we're proposing here. And that's about it, I think, right? Yeah. So that's the proposal. Any comments, suggesting? I know that there was some support for this work on the mailing list. And any comments?
I'd like to stress first that this is not a current working group document.
There's no document yet.
There's no document yet?
Nope.
Oh.
No document.
Okay. And I think so. We're fine to discuss it here. We've allocated about 10 minutes for this, and it's fine. We can overflow because Alexei kept it brief. But the working group has yet to decide whether it wants to accept it, and we still have a lot of other work to do before we adopt new stuff. Having said that, I think the obvious question is, this changes the crypto. Has anybody looked at this and said, yes, this is good crypto? Anybody that we trust?
Yuta Koiba speaking. So before taking this, we first need to clarify correctly the security implication of the extension. So adding new things just in the simple way to the hash is easy, but it is not always clear that such modification actually gives more security or not. So especially for salt, we need very clear analysis of the security gain, and we must describe it clearly in the security consideration section. So
I think that the salt, I don't think that the salt thing was for security reasons. Is mainly for the use case that database, for example, is compromised, and they don't want to change the realms. Instead, they just change that salt to keep those realms intact, right? So that's
actually, honestly speaking, if it's the only reason I don't like this idea, because this kind of hashing is always victim of the password dictionary attack. So the use of the same password, just changing the salt is very dangerous in some cases. So we must be very clear about that.
Adding the salt doesn't really change that.
I don't think it gives a better security solution.
Again, the claim is not.
That it's a security issue, so.
Okay. I don't think the claim was that it adds any, from a security perspective, that it adds much value, right?
In other words, is it actually safe to reuse the same password, only changing the salt in such situation?
No. The password will be changed for sure. It's the realm that they want to change, right? The password will change. Mm-hmm. If the database is compromised, that password is done.
Case, why you don't want realm to be changed? If user has to change all password,
because you have to touch different servers to do that. If you change the salt, you just send that.
So can you clearly present such use case in the slide or something like that?
Maybe. Again, Like that was. Do you have any use case example for this? Like, yeah, go ahead.
Yes, so marketing, I am one of the co-editor of the standards. So the idea is that if the database is compromised and you don't want to change your reading, you just obviously need new password, but to change so you do not have to change the reading.
But if all users must change password, is it any difference from just invalidates all existing entry and introduce new password entry?
Except if the user reuses the same password.
But at least it said it's very dangerous situation.
Yes.
Okay, so I'm go ahead.
Just repeat what goes on the wire.
What goes on the wire?
Yeah.
You just add the salt to what you hash. So the hash, instead of hashing username, realm, and password, you hash username, realm, password, and salt, right?
Don't have the proposal in front of me, so
Okay,
some of it is on the previous
right.
slide.
So the A1, instead of username, realm, password, you just add salt and the hash of. Go ahead.
Yeah, so I'm wondering if the password database has to change because of this.
So typically in those use cases there, we're talking about a salt per database is not a salt per user, right?
Mm-hmm.
So
if you look at one of the secure PAKE things like the SRP that you're going to talk about next, these usually mean that the server has to store the actual passwords rather than a salted hash database. It's almost always correct.
So
SRP,
what?
yeah, because with SRP the server and client are doing some collective calculation, the server has to have the clear text password.
No, not with SRP, but we're talking about this one here.
Okay. So this doesn't have such an implication for the server. The database can stay the same database that you would use for regular database.
Yeah, I don't. Yeah, there is no clear text password, right?
It's not clear text, but we often say the password equivalent because it is directly useful for the authentication.
But that doesn't change anything. That's the existing situation. Again, there is no claim here that the salt would add any security value here, right? That's not what the claim, right? The claim is it's for convenient reasons. If that database is compromised, they don't want to force every element to change their own. Instead, just change the salt on the server, right?
Yaron Sheffer. I'm not a cryptographer, but this looks like an abuse of HMAC to me.
Now you're talking about the second one?
Yeah.
Okay.
I mean, HMAC is a MAC. It assumes a secret value, and now we're using it as just a little bit more mixing of, I mean,
it's still
the verified hash. So
no, it's what's today that the digest mechanism saves that HA1, right? This is the password that.
I can see SHA-256. I don't know what HMAC is doing down there. Okay,
so again, the idea is that KD function today, that the way it is used today is just concatenating the HA1 with the rest, right, and then hash it, right?
Okay.
Instead of doing that, because there's a need for a really keyed mechanism, instead of doing that, you use the HA1 as the key and the rest as the message itself, right?
So wait, where is A2 coming from? Or we're not there yet?
HA2?
HA2.
No, like it doesn't affect the calculation here, right? HA2 is staying the same thing, right? We're not, it's HA1 that is changing, and the KD function that will change, right?
What is A2?
Oh, what's A2? It's I don't remember the details. Like it's yeah. No, I don't have it here. Okay, it's not changing,
Is
right?
it a secret?
No, it's not a secret value. No.
I'm confused.
No, HA1 is secret, right?
Again,
HA1 is the secret that is stored on the database, right?
again, we need some layer meaning of introducing the HMAP in the clear
Sure.
description. So without that, if the security strengths of these two parameters are similar, just concatenating and hashing is fine. So we need a clear reason why we put H1 on the left-hand side and other things to the right-hand side. And for the sort-state hash issue, if hearing the current discussion, I'm strongly against adopting this technique because it gives a very bad confusion to the users. So we must clearly say what is the gain and what is the meaning of that consequence. So if password database is leaked, we should do in this way instead of this way, so that security issue will not be getting worse. So with that such kind of description, I'm currently against taking this to the standard or any stage of protocol exchange.
Okay.
Hi, Kenny Patterson, and I am a cryptographer.
Oh, good. We have somebody.
And under the assumption that the only secret value here is password, and everything else is known to the adversary, this proposal adds no extra security on top of just hashing.
Okay.
No extra security.
Okay.
You can't magic up entropy out of nothing
Right.
if your only secret is a password.
Correct.
So
Yeah.
maybe there's some reason why you want to have a key derivation function here, some exterior reason, but it cannot be security.
Okay.
Thank you.
Okay. Thanks. Okay.
Okay, anything else? Okay, so the response has been kind of negative. If you or others still think it's a good idea, please submit a draft and then we can have more concrete responses to that.
Yeah, that's the reason I did not submit the draft, right?
Okay. So get your other one up. Just have to make sure it opens with the non-beta version. There.
Okay, so Yaron and I have been discussing different options for replacing digest with a better mechanism. So this is kind of a result of that discussion. So next slide, please. So the proposal here is to use SRP as a mechanism to replace digest. So some background about SRP is a royalty-free protocol, well-defined. It's been defined and used by different IETF RFCs. It's defined in the first one, and it's used by the other two there. It's with the telnet and TLS. And it has a variety of implementations implemented already, and many people use it already. Next slide, please. So a secure remote password is an augmented big password that is used to authenticate users using some shared key or shared secret on both sides. As a result of that, you get you create a shared key at the end of that process, and it doesn't require any PKI or trusted third party. So this is the high level. Next slide, please. So at the high level, we're talking about a framework that is based on SRP on top of the existing HTTP framework. That could be used for HTTP, SIP, other protocols that use that challenge response mechanism. We're not expecting this to be used for generic web traffic. It's resistant to phishing, so if you go to a wrong website, you don't expose any information about that password. and resistant to dictionary attacks. Next slide, please. So at the beginning, there is a setup on the server side. So the server will use a large prime and a generator. And then when a user account is created, the server selects a hash function and a user salt. In this case, the salt is user specific. And it uses a realm and a password to create a password verifier. The password verifier is created using two steps. The first one is derived key, private key, which is the hash of the username, realm, password, and salt. And then that password verifier is a generator to the power of that derived private key, modulo large prime. All the calculations are modulo large prime. And then that data is stored in the database. Notice that the derived private key is not stored in the database. So that nor the hash or the password itself is never stored in the database, right? Next slide, please. So this is just to the authentication process requires the first initial request to include the username. So if the username is not known to the client, this is a way just to kind of discover that. And Yutaka, you have a few comments about this, and we can adjust it to that. So this is just the discovery process. Next one, please. So that authentication process starts by the client sending the username to the server. The server uses that username to fetch the information about that user, that password verifier, and then challenges that request. Includes the large primes, generator, the hash algorithm, assault, and that server's public key creates a server public key for that specific session and sends that back to the client. The client gets that information, creates the client public key on its side, creates a session key, and creates a client proof of possession to make sure or tell the server that it is now in possession of that session key, and send that information back to the server. The server uses that server's public key to associate those two requests, and then verifies that client POP and creates that session locally and sends a service POP back to the client, and the client verifies that. Right? But at the high level, that's the process. Next slide, please. So benefits. Resistant to passive and active attacks. It provides a perfect forward secrecy, and again, it never stores passwords or hashes on the database, only the password verifier. So if that is compromised, the attacker can't use those verifiers to compromise the system, right? So these are the benefits of this method. And that's about it, I think. Next slide, please. That's it. Questions, comments?
I'm Yutaka. So as far as I heard from you, it's a functional subset of the mutual authentication currently. So the mutual authentication is actually how the PAIC, augmented PAIC, can be implemented as HTTP, both for web and non-web traffic. So I already considered both use cases, and it is also designed as a algorithm agility. So you can use SRP just by putting the mathematical equation into it. So please read my draft.
Sure, I'll read that. But like one of the advantages of SRP is that it's already implemented, widely used.
In that case, you can just put the my draft is composed of the basic framework and algorithm, so you can just write algorithm part of the SRP to use the mutual authentication.
Okay, I'll take a look at.
And also for technical things, so phishing is not just stealing the password. So to prevent any kinds of the phishing attacks, you must have a channel binding.
A channel binding.
Yeah. Okay. Without that, the attacker can forward the request and perform the successful authentication, and the attacker can steal the payload of the HTTP traffic. So you definitely need channel binding.
Okay. Any other comments?
Yeah, Shep, I think this is, so technically I agree with you about channel binding. Formally, I think you're sort of extending the definition of phishing. But yeah, channel binding would be needed, even though SRP as is resistant to phishing. And one more technical comment, my responsibility, we noted that this is resistant to dictionary attacks on the server, and this is actually incorrect, as far as I can see.
Okay.
Okay, and I'll remind everyone that this still is not a working group draft.
Yeah.
And we're still doing our own draft, and then we'll see if we can adapt more.
Yeah, just on phishing, I had a whole big argument with Stephen on this. I have a much broader definition of it because it involves lots of different attack types. It can steal all sorts of credentials. It can download malware onto systems. It's really big. So it's not narrow.
Speaking with no hats, to me, phishing is a social attack.
Yes.
People can convince you to do all sorts of things with the best intentions, and it's really hard to stop them from doing it technically.
Tony Hansen, when you do write this up as a draft, I suggest you follow the example that Alexei did with base64 encoding, the set of stuff that gets passed into the algorithm, so that it's then encapsulated as a single chunk that just passed to the implementations.
So we do have a draft for this one.
Okay.
Yeah. So, but yeah, okay.
I encourage you to follow his example.
Sure, I'll take a look.
For that data block.
Okay, thank you.
Okay.
Any other comments?
Anything else?
Any cryptographer here?
Well, cryptographer is not going to say anything against SRP. It's not yet.
Okay. Okay. Thank you, guys.
Okay, we've been doing things rather quickly, so we reached the time for open mic.
Just an announcement from the author of the military authentication. As
Oh yes,
Yersan already said, I published the current XML source of my draft to the GitHub. So, of course, I'm not asking you to rewrite my document, but if you find it is helpful for you, please feel free to use it and submit even a pull request for that. But of course, you can ask me to change the draft text. So.
Pull requests are fine, and we did mention in the previous session that the drafts need some work on at least language, and those are perfect for pull requests. So if anybody volunteers to do that, they'll. I think we have some stars somewhere here. Yeah. So anything else? Good. Then we'll adjourn early, and we can get at the cookies before all the others. All right. Okay. Party games. There are too few of them. We went through them in 10 minutes. Okay, so did everybody sign the blue sheet? If you haven't, please find it. It's probably somewhere in the back. Yeah, there it is. Just sign it and bring it back here.